Hello friends, welcome to Learner's Planet. Friends, this is our second session for rational numbers. In the previous session, we discussed various types of numbers. We discussed about natural numbers, whole numbers, integers, positive and negative integers. Then we discussed about rational numbers. We did some problems based on addition of rational numbers. In this session, we are going to discuss about the properties of rational numbers. Okay, so let's begin this session. So here we are going to discuss about properties of addition of rational numbers. Properties of addition of rational numbers. Okay, now the very first thing is closure property. Now what's closure property? The sum of two rational numbers will always be a rational number. The sum of two rational numbers will be a rational number. Right? You can take any example, maybe P by Q plus R by S. So the sum of P by Q and R by S will be a rational number only. Okay, you can take a numerical example also, maybe 1 by 2 plus 1 by 3, that is 5 by 6. So this is a rational number, this is a rational number. If you add both of them, still you will be getting a rational number. Okay, so sum of two rational numbers will always be a rational number. That's very important property. We know this property as closure property. Okay, next is commutativity. Now what commutativity is? See, if you add two numbers, suppose you have two numbers 2 plus 3, right? So you can write them in other order also. So the answer will remain same. So 2 plus 3 will be equal to 3 plus 2, right? So while you are making an addition, order of the numbers doesn't matter, right? Okay, so A by B plus P by Q will be equal to P by Q plus A by B, right? So order of addition doesn't matter whether you write this way or this way. Okay, you can take one numerical example also. Suppose I have 4 by 5 plus 3 by 4, so that will be equal to 3 by 4 plus 4 by 5. Just add both of them. So it's 16 plus 15, that is 31 by 20, and that is also 31 by 20, right? So order doesn't matter, and the property is known as commutativity, right? In exams you may be asked to establish this property, so you have to proceed this way. You have to add both of the numbers in the both the orders, and you have to prove them to be equal, right? Next is associativity. So what associativity is? Suppose we have three rational numbers, maybe A, B and C, or maybe you can take P by Q, R by S and X by Y, right? So suppose we have three rational numbers. So in that case, what would happen? P by Q plus R by S plus X by Y is equal to P by Q plus R by S plus X by Y, right? So the addition of rational numbers is associative, and in any order you can take them. Okay, you can take numerical example also. Suppose the numbers which I am having is 1 upon 2, 1 upon 3 and maybe 2 by 3, right? Suppose I have these three rational numbers. So 1 upon 2 plus 1 upon 3 plus 2 by 3 will be equal to 1 upon 2 plus 1 upon 3 plus 2 by 3, right? So this is what? 3 by 2, and this is also 3 by 2, right? So addition of rational numbers is associative, right? So we proved the three things. We discussed the three things: closure property, commutativity, and associativity. Next is existence of additive identity. Okay, that means the sum of any rational numbers and 0 will also be the rational number. Suppose I have a rational number x by y. If I add 0 to it, still I'll be getting x by y only. Okay, so x by y plus 0 is x by y, or 0 plus x by y. Okay, so all the three things are same. So if we add 0 to any rational number, we'll be getting answer as that particular rational number only. Then we have existence of negative, or we can say additive inverse. Okay, existence of negative or additive inverse of a rational number, right? Suppose we have two rational numbers a by b and c by d. So if a by b plus c by d is 0, if a by b plus c by d is 0, then we will call c by d is as negative of a by b, right? That means a by b is equal to minus c by d. So both the numbers, like whether a by b and c by d, both the numbers are negative of each other, or we can say additive inverse of each other. Okay, because c by d will also be equal to minus a by b, right? So a by b is minus c by d, c by d is minus a by b, so both of them are negative of each other, or we can say additive inverse of each other. I take a simple example. What is additive inverse of maybe 4 by 3? So 4 by 3, and we have to find out its additive inverse. Suppose that is x, right? So if I add x to 4 by 3, I should be getting 0. That means x is equal to minus 4 by 3. So additive inverse will be what? Like if you are having positive sign over here, so just put a negative sign, and if you are having a negative sign, you have to get a positive sign, right? So additive inverse of 5 is minus 5, additive inverse of 2 by 3 is minus 2 by 3, additive inverse of maybe minus 5 by 6 is 5 by 6, right? The sum of these two must be 0 to make a pair of additive inverse. Okay, so getting me? Now for this particular set of numbers, rational numbers, we have to verify the commutativity of addition of rational numbers, right? So what we do, I just add this, okay, and here I add this. Okay, now how do we solve it? It's 35. 5 into 7, the 35 is LCM of 5 and 7. So now 5 into 7, that 7 into minus 11 is minus 77, plus 7 into 5, and that 5 into 4 is 20. So what we are getting over here? Minus 57 by 35, right? Similarly over here, it's 35, 7 into 5, 5 into 4, 20, minus 5 sevens are, and 7 into 11, 77. So here also we are getting the same thing, right? That means a plus b is equal to b plus a, or you can present that p by q plus r by s is equal to r by s plus p by q, right? So this is how we can verify the property of like this commutativity of maybe we can say addition of rational numbers. Okay, you can take various examples and it's really easy to establish, so I won't be taking many problems of that. You just have to add these two numbers in two orders, like this and like this. Okay. In this case, we have to verify associativity of addition of rational numbers. Relationship we are given, that is x plus y plus z is equal to x plus y plus z, that we have to prove, and the values of x, y and z are given, right? So first of all, we put the values of x, y and z in here, and then we'll be putting the values of x, y, z over here. Let's see we get the answer equal or not, right? So here x is what, 1 upon 2, y is 2 by 3 plus z is minus 1 by 5. So it's 6, 2 3s are 3 plus 3 2, 2 2s are 4. So it's 7 by 6 minus 1 by 5. I take LCM. 6 5s are and 5 into 7 35 minus 5 6 are, 6 into 1 is 6. So it is 29 by 30. Now let's see what happens in this case. I put the value of x, y, z over here. So x is half, y is 2 by 3 and z is minus 1 by 5. Okay, so it's half plus 2 by 3 minus 1 by 5. So it's half plus, take LCM, that will be 15. 3 5s are, so 5 2s are 10 minus 5 3s are, so 3 1s are 3. Okay, so it's half plus 7 by 15. Further take LCM, it will be 30. Now 2 into 15 is 30, so 15 into 1 is 15 plus 15 into 2 is 30, so that 2 into this 7 is 14. So this is also 29 by 30. So this and this is same, right? So we can very well verify associativity of addition of rational numbers. Okay. Now here we have to write the negative of each of the following, that is additive inverse. Now I have already told you, if it's negative sign over there, then additive inverse will be positive, right? So minus 2 by 5 plus 2 by 5 will be 0. And minus is there in the denominator or numerator, it doesn't matter, right? Okay, it will give you the same value. So it's 7 by minus 9, so the additive inverse will be only 7 by 9. Okay, here minus 16 by 13, so the additive inverse will be 16 by 13. Here it's minus 5, so the additive inverse will be 5. Additive inverse of 0 will be 0. Similarly, if we have to find out the additive inverse of 2 by 5, it will be minus 2 by 5, right? So if you add these two, you'll be getting 0. These two, if they are added, still you'll be getting 0. Okay, so in every case, if you add the two numbers, you'll be getting 0. Okay, so this is how we can find out the additive inverse of a given number. Now friends, here using commutativity and associativity of addition of rational numbers, we have to simplify this expression, right? Now what is the first step? Just listen to me carefully. Here we can see here and here the denominator is 5. So we take these two terms together. Okay, then here and here the denominator is 3, so we take these two terms together. Okay, since the addition of rational number is commutative and associative, now we simplify this bracket and this bracket as well. So it's 2 by 5 minus 4 by 5, and this is 7 by 3 minus 1 by 3. Now what? In this case, the denominator is same, so we can add as it is. It's 2 minus 4 plus this is 3, 7 minus 1, that is 6. Okay, now 2 minus 4 is what? Minus 2 by 5 plus 6 by 3 is what? 2 by 1. Okay, now further take LCM of 1 and 5, it will be 5. Now 5 into 1 is 5, so that 1 into minus 2 will be minus 2 plus 1 into 5 will be 5, so that 5 into 2 is 10. Minus 2 plus 10 is what? 8 by 5. Okay, so this is how we can simply solve the problem. Okay, just arrange the numbers which are having the same denominators together, then solve it like this. Okay, I take one more example. Now let's do this problem. We take these two together, 3 by 7 minus 11 by 7 plus these two together minus 4 by 9 plus 7 by 9. Now denominator is same, take it as common, then it is 3 minus 11 plus this is 9, so it's minus 4 plus 7. Now 3 minus 11 is what? Minus 8, this is by 7 plus this is 3 by 9. Okay, so it's minus 8 by 7 plus 1 by 3. Now further we have to take LCM of 7 and 3, it's 21. 7 into 3 is 21, so that 3 into 8 is 24, and we have negative sign over here, plus 3 into 7 is 21, so that 7 into 1 is 7. Now minus 24 plus 7 will be minus 17 by 21. Okay, so very simply we have solved this problem just by rearranging the numbers. Okay, now here we have 5 terms, so let's arrange them. This 2 by 5 plus 4 by 5, then 8 by 3 minus 2 by 3 plus 11, it's minus 11 by 15. Okay, now solve this. LCM will be 5, 2 plus 4, 6 plus this is 3, 8 minus 2 is 6, and this is minus 11 by 15. Okay, now we have 6 by 5 plus 6 by 3, or we can say by 11 by 15. You can even write it as 2 also, and if you don't write then also no problem. Now we have to take LCM of 5, 3 and 15, right? So LCM of 5, 3 and 15 will be 15 only. Now 5 into 3 is 15, so that 3 into 6, it is 18. Similarly 3 5s are 15, so that 5 into the 6, 5 6 are 30, minus 15 into 1 is 15, so that 1 into 11 is 11, right? So this is 30 plus 18, that is 48, minus 11 by 15, so it is 37 by 15, as simple as that. Okay, so by rearranging the problem becomes very simple to solve. Now rearrange suitably and find the sum of the following, right? So we have to simplify this expression. Here we take these two together, so it's 11 by 2 minus 25 by 2 plus 11 by 12 minus 17 by 3. Okay, now denominator is same, so 11 minus 25 by 2 plus 11 by 12 minus 17 by 3. So 11 minus 25 is minus 14 by 2 plus 11 by 12 minus 17 by 3, right? Now we can take LCM. LCM of 2, 12 and 3 will be 12 only. Now 2, 6 are 12. So that 6 into 14 is 84 with a negative sign. Okay. Plus 12 into 1 is 12. So that 1 into 11 will be 11. Minus 3 into 4 is 12. So that 4 into 17 is 68. Right. So if you solve, it's 4 and 8, 12, 8 and 6, 14 plus 1, 15. Okay, so it's 152 minus 152 plus 11 will be minus 141 by 12. Okay, so I hope you are getting this thing, how to add rational numbers. Now let's simplify this. Here we have this with same denominator, then this and this, then this. Now 7 by 3 and this is minus 7 by 3. So these are additive inverse of each other. So we'll be getting 0 over here. So this is 0. Now here the LCM is 5. 3 plus 9 and this is minus 13 by 15. Now 3 plus 9 is 12. So it's 12 by 5 minus 13 by 15. Okay. Now take LCM of 5 and 15, that's 15 only. Now 5 into 3 is 15, so that 3 into 12, 36. 15, 1 is 15, so 1 into 13 is 13. So 36 minus 13 is 23 and this is by 15. Right? So this is how we can solve it. So friends, I hope you might have enjoyed this session. In the next session, we'll be discussing about the subtraction of rational number. Okay, do revise this session and the previous session as well, so you feel comfortable in the forthcoming sessions. Yeah, bye-bye.